I'm BIS Sawadogo. I am an associate professor in industrial engineering at the International Institute of Water and Environment in Ouagadougou, Burkina Faso. My co-authors are Anthony Benoit, Abdul Fares Diallo, and Marie-Louise Somda. I will present you today our work about assessing the environmental impacts of dried mango industry in Burkina Faso using life cycle assessment. This presentation will be in 4 points. The first one is the introduction, methodology, results and discussion, and the conclusion. Mango industry in Burkina Faso has a potential estimated at more than 300,000 tons per year. This industry is facing post-harvesting losses, so drying mango became an opportunity to reduce these losses. For drying mango, we have many SMEs in Burkina Faso, but the problem in these SMEs is that they use important quantity of energy. This energy consumption is in terms of butane gas consumption for drying and electricity. For butane gas, for example, the drying process requires minimum 0.6 tons of gas per ton of dry mango. So these energy requirements are, for example, 20 kilowatt for 100 kilogram of fresh mango. So drying mango has many processes going from fresh mango, washing step, peeling, slicing, and drying. During this process, we have a large amount of waste that is produced consisting of skins, pulp, and pits. This waste can be recovered as energy in these industries. Our purpose here is to assess the environmental impact of this process. So what is the environmental impact of producing dried mango? To do that, we use LCA. LCA methodology is a standard methodology standardized by ISO 14040 and 14044. This methodology is in 4 steps. The first one is to define the goal and the scope of the study. After defining the goal and the scope, the second step is the inventory analysis. After the inventory analysis, the third one is the impact assessment using an LCA software. And the fourth step is the interpretation, and then some recommendation has to be made. As I said, LCA is a standardized evaluation method used to produce a multi-criteria, multi-stage environmental assessment of an entire life cycle of a system or a product. For our study, we will focus on 2 SMEs in Burkina Faso. The end products are dried mango. For mango sector, you have many steps. First step is the farm for cultivation, harvesting. After this step, you have a transportation of the fresh mango into carts to the drying plants. At the drying plants, you have a drying of the fresh mango to obtain the final product that is the dried mango that will be transported into the distribution centers or the stores. For our study, we only focus on the process, the drying process. So we use a gate-to-gate methodology to do our LCA. Our functional unit is 1 ton of dried mango in this study. For the inventory management, some data from the field. The primary data have been collected during SME's diagnostics. During this diagnostic, we have collected some data about the activity, so the inputs and the outputs for each step of the process. These inputs are the fuel consumption, the quantity of fuel purchased, the quantity of energy consumed, the volumes of water consumed, the quantity of waste, smoke, and so on. We also used LCA generic database for our analysis and also literature review for some of the data. So if you see, for example, here about the life cycle of the gate-to-gate life cycle of our mango processing, we go to fresh mango and then second step is sorting and washing. At this step, you have the use of water and bleach water, and the output is wastewater. Next step is peeling, slicing, where you have some residues here, mango peels and mango pits. The drying process, at this step, you have as input electricity and butane gas, and then you have the conditioning and the dried mango as end product. To implement our model, we used a software, an LCA software that is CIMEPRO. The database that is used here is EcoInvent, and the method is a recipe. We have assessed 8 criteria, 8 environmental categories impact, but here I will present you 7 of them. That is climate change, ozone depletion, acidification potential, particulate matter, water scarcity, human toxicity, and ecotoxicity. After implementing our model on CIMAPRO, we have obtained some results. Here, I will present you the midpoints results for our LCA. For these results, you can see that the green part, the green step is the one that have the most impact for the 7 categories. This part is drying step. This is due to the consumption of butane gas and electricity. Also, for the global warming, we have some impacts in terms of the methanization of the mango residues. So as CO2 emission, we can see that in this industry, we have 0.87 tons of CO2 per ton of dried mango. And the main contributing steps are drying and slicing, due to, as I say, methanization of cutting waste. For the second SMEs, we have the same trend. We saw that the drying step is also the main contributing part, and the slicing due to the methanization of the residues has an impact that is not negligible. So when focusing on the CO2 emission, we can compare these two SMEs. Comparing these two SMEs show us that the first one has more like two times the impact of the SME2. This is due to the inefficiency of the equipment in these SMEs, the consumption of water from the national company. And the second one has in-ground water that it used in his company. So drilled water and the use of bleach are the most impacting factors, and also the use of gas and electricity. To conclude, in this study, we did a gate-to-gate life cycle analysis of SMEs producing dried mango. The analysis showed that energy consumption, particularly butane gas, is the main source of environmental impacts. Water consumption has also some impact, in the methane production from mango residues. As recommendation, we recommend to convert the waste like pits, skins, pulps, the waste of the mango into biogas. Also, in this in the region that these SMEs are, you have the production of cashew nut shells. Donc, this cashew nut shell can be used in this industry to convert it into energy and use in mango industries. We also recommend the use of groundwater instead of the national company water to reduce the impact in terms of water consumption. Thank you for your attention.